Okay, so the last time we were discussing example 1, and we wanted to see um, what can we do if we are given a question like this, where the population um, was given for the year 2003 and 2007. And from those two given information, we wanted to generalize things to find the equation for future values. You know, uh, we want to calculate what would be the population after a certain time. And for that, we quickly go back to where we were last time. So, okay, so I'll start sharing the screen of my iPad. So if you have the book in front of you of any format, please have that open. I'll start sharing the screen now.
What page are we on in the book?
So we are on page 175.
Okay, thank you.
Okay, so as you can see, the last time we wanted to see what can we derive from this, and of course, later on we want to solve it for the year 2014, and you can clearly understand that for this explicit form, sorry, this time n, that means the time duration is actually in years, because we are given information for certain years, as you can see. Okay, so let's quickly start discussion today. We had a quick recap. Now, if you remember, for an equation like this, we said m is our slope and b is our y-intercept, right? And we actually say that we can relate this to our, let's do it this way. We can relate this to the explicit form as well. So let's see what's the relation here. So if you remember this, let me rewrite it this way instead of writing this, so that you can actually see it's kind of resemblance of what we have in the equation above this one. So this is again the y-intercept, and this is the slope. You can see it definitely looks pretty similar, the format I'm talking about. Okay, so let's find the slope then. We know the slope is the change in output over the change in input. Now, the question would be, what's my output here? And what could be my input? So you can remember, or if you can see this, see the question for 2003 and 2007, the population was given, which is 12,017 or 15, okay, 15,000 respectively. So if you want to graph or if you want to visualize things for these values, we have corresponding values of this. That means we can say that the values in year is our input and the population is our output, because you can graph it this way, right? So we want to use these informations to find our slope. So it would be 15,000 minus 12,000, and the change in x values, that means the input values, would be 2007 minus 2003, right? And this would be 3,000 over 4, which is equivalent to write as 750. There is no hardcore calculation here, to be honest. You can eyeball the outputs. This is for this, and of course, this one is for this. If you simply divide it, you'll get 750. So this is our D. Okay, now what's our y-intercept or P naught on this occasion? So if you remember, for y equals mx plus b, the equation of this format, we said we can calculate b by just plugging in x equals 0, right? So for p no, pn rather equals to tn plus p naught of this format, the explicit format I'm talking about, we can clearly see that we can calculate the p naught, which is the y-intercept here, by just plugging in n equals 0. So for n equals 0, that means when we started, our initial population, given population was 12,000. So that means for this particular problem, our P naught would be 12,000. Since this n was the time duration given in year, that means this n equals 0 means this is the first year's population. That means the population what we started with. And you can clearly see the starting population was 12,000. So even though we didn't really plug in and calculate anything, we can actually see it from the given informations. So P naught is 12,000. Now, finally, we're here. So we know Pn equals to P, or P naught rather, and now we have the informations, which is D is 750 times N, which is in years, of course, and P naught is 12,000. So finally, we have the explicit form. This will be our explicit form. Okay. Now, what would be the recursive form? So if you remember, recursive form looks like this. Right? Where P naught is the starting value and Pn minus 1 is the population for this particular problem, of course, not for every problem. It could be something else depending on the given information. But for this particular problem, we're considering the population. So this will be the population of the previous year. And if we know the population of the previous year and the starting population, we can actually get the population of the current year. So this is the recursive form, okay? So we'll use the explicit format now to find, let me write in the known format now. So it's the explicit format. And we want to find the population for the year 2014. Okay. So we want to find it for 2014. We started from 2003. So can you tell me what would be my n, the number of years? If we can, yeah, go for it.
It would be 11.
Okay, so excuse me. So clearly you can see we started from 2003. We're looking for the population in 2014. So that means we just want to calculate what will be the population after 11 years. Okay, so if we just plug in 11 here, so P of 11, 750 times 11 plus 12,000. And what would be 750 times 11? Use my calculator. You can use yours as well. It would be 8,250. So overall, it will be 20,250. So this is the final result. After all these calculations, we are here to get our final result. This is the final result. This is the number of elk in the year 2014. If, of course, if it continues to grow like the way we have given. Okay, now let's take a minute or two if you have any question.
I got a question.
Yeah, sure.
Could you use the recursive form to solve this as well?
Yeah, sure, of course. I'll do that actually. But let me first see if you have any question from the explicit form. Anyone? Any question? No question at all? Very good. So now let's see what it would look like if we can solve, if you want to solve for, or rather using the recursive form. Now, if you want to solve using the recursive form, you can clearly see we need to have the population of the previous year. That means if we want to calculate, excuse me, if we want to calculate P11, we definitely need P10 plus, of course, P0. And for P10, we would need P9. For P9, we need P8. So it goes like this. That's why obviously it's been named, or it's known by the word recursive. So that's the problem. That's why for a really long time duration, we avoid the recursive form. It's quite easy calculate using, sorry, any question? Okay, so we want to use the explicit form rather clearly because if we can find the slope, um, it will be much easier for us to find the population even for a really, really large number. We can even calculate, for example, for the year, or even later. We can year for the we can calculate it for the year um, um, for after even after 1,000 years, we can easily calculate it. But for the recursive format, um, if you go for a larger number, it gets really, really time consuming. So let's just see how does it work. We'll not solve it for 11 years because it will take the entire class time. So let's see what will happen excuse me, in the year 2008. Okay, we started from 2003. So we'll have 5 years to calculate. So we need to have P4. And for P4, we need to have P3. For P3, we'll need P2. I'm just using the recursive format to run this loop using the same formula. Pn equals Pn minus 1 plus P naught. So this is for P5. You can see we can use the same formula for P4 to get this. We can keep going on for P3. We'll get this. This P naught comes from here. And finally, we'll have for P2, we'll have P1 plus P naught. This will become 3P naught. Just adding those, nothing else. I can use this. So this will be for P1. Excuse me. So we can find it now. So P naught will have 4 P naught. P1 plus 4 P naught. And now what would be our P naught, P1? So P1 would be the population after year 1. And for that, do you have the information? Let me see.
12,000.
So P naught is 12,000. I'm looking for P1 instead. Okay, so it would be our P1. So P1 would be P naught plus P naught plus 4 P naught, using the same formula, of course. So it's P naught plus 4 P naught. Five P naught. I guess we have lack of information here because we can't really say that P1 equals to P0 plus P0, because what it means, P0 plus P0 means 2 P0. That means in the first year, we are saying that it's actually getting doubled. But that's not the case. So we can't really use this information here. We need to have P1, or we need to have P1, or since we have the information for 2007, which is P4, we can use that. So P4 plus P0, and what's the population in 2007? Example 1, it's
15,000.
15,000. Okay. So P4 is 15,000, but is it true using the recursive form? May not be, because it's not really coming from, or rather we have not derived it from any formula. It's actually given. So that's why I said we need to have the information for the first year for this. Okay.
That makes sense.
So this is not going to work in this way if the population is given in this format. So we need to have, for example, we need to have a table. So let's see one example of this. So let's say we have example 2. We have something like example 2. Then we can use the recursive format, because you can see we actually know the value of the previous year. That's when we can actually use the recursive form. Otherwise, you can see this doesn't really make sense, because if we keep going like this, it's literally saying that the population is getting 5 times more in 5 years, which is definitely not true. So that means you can use the recursive form once you know the population of previous years. So simply it looks like example 2. And again, I said in my exam or in the homework, you'll be just asked to write the recursive format. Just write it. You will not be asked to solve it using the recursive format, because you can see it takes a lot of time. Instead, you'll be asked to solve it using the explicit format, because for that, using that, you can actually solve it for a huge number. Doesn't matter how long the time duration is. So as we have arrived here, let's quickly see example 2 as well, and let's see whether it makes sense or not. Okay. Now example 2. Okay, so it says gasoline consumption in the US has been increasing steadily. Consumption data from 1992 to 2004 is shown below. You can see the table. Find a model for this data, use it to predict consumption in 2016. If the trend continues, when will the consumption reach 200 billion gallons? Okay, all right. So you can see we need to do a couple of things to solve it to solve the entire problem. So once again, we want to use the explicit format, because we'll start from 2000, or rather 1992, and we want to go up to 2016. So you can see we are looking for a large time duration. Okay, And if we consider this as n equals 0, that means the starting year. So that means we are looking for um, the consumption after 23 years, right? Because this is a time duration of 24 years. And if we say that this is n equals 0, the starting year, that means we are looking for the uh, consumption after 23 years from there. Okay, so once again, we want to solve and find D and P naught. And clearly then we can calculate P of 23 using 23 times D plus P naught, right? Which is N. N is 23 here. Okay, now let's quickly solve it. What's our P naught? We can clearly eyeball it because it's given. P naught is 110, I believe. Yeah. Okay. So it's 1 on, or okay. So 19. Okay. What it says, 1992 and from 2004. Okay, so they have used 1993. I'm wondering why. Let's just see. Okay. Oh, okay. Okay, so they have considered this is the year ending data. Okay, but is it year ending data? Consumption data from 1992. Okay, so they have a side note here. Transportation statistics. Okay, and after 1990. Okay, so that's at the end of 1992. All right, so 20. Oh, okay, yeah. So 2016 minus 1992 is 24, and we are considering the year ending data. Okay, so all right. So let's say, we see why they have used 1993, whether it makes sense or not, because it could be a typo. Let me just check. Yeah, they have used 1993 everywhere. I'm wondering why, because they have data from 1992. '16, and we have 7 more years. It should be 1992. I think that that's a mistake in the book. I can't see why they have used 1993. I can't see why. Anyway, so I've done a mistake as well. This should be 24 years though. Yeah, this should be 24 years because this is the year ending data. So it's just like a baby born in 1992, and we are considering his or her age in 2016. So it's 24, it's going to be 24. So let's just erase this. We'll do it for 1992, not 1993. I'm not sure why they have done that, but we can clearly avoid it. So we can find it for 24 years. Okay. All right. So the starting value, of course, it will be 110 in 1992. It will be P naught. It will be 110. Of course, in billions, that's billion of gallons. And the D, so for D, fortunately, we have more than one information here. So you can take any time duration and um, solve it for D. So let's take the entire duration, no problem. Where is the table? The table is, okay. 13, 23. So let's take 2004 minus 1992, and the change in output will be 36 minus 110. Yeah, and it would be 26 over
24?
Yeah, 24, and it would be 26 over 24, which is 1.08.
I have a quick question.
Yeah.
I may have done it wrong, but I took the difference of, because I thought it was 24 as well, and then I just took the difference of from 2004 to 1992, and I didn't get 24.
How much did you get?
I got 12. I may be missing something though, so I don't know.
Oh, sorry. My bad. I'm actually looking for 2016. That's the difficulty of looking at two different screens at the same time. Yeah, it's 12, definitely. Yeah. I was looking for 2016. Sorry for that. My bad. So that's the answer we're looking for, not here, by the way. Okay, so 26 over 12. Let's see, what's that? 26 over 12. So it's 2.17. So it's 2.17. Okay. And you can see it's not exactly what they have in the book, and that makes sense. Do you know why? Because this y equals mx plus b is a linear equation. Now, what's a linear equation look like? What does it look like? So if you draw a line like this, wherever you want it to draw it from, doesn't matter. So this will be a straight line. This will be a straight line where it intersects. Let's do it this way, where it intersects the y-axis at this point B. This will definitely be a straight line. But if you look at the graph, even though you don't have a graph for it, you can see it from the table, it will not be a straight line, since you can see in 1 year it has increased 1 billion gallon. The next year it has increased 2 billion gallons. The next year it has increased 3. And the next year it has increased 2. The next year it has increased 1. So that means there is a discrepancy in between. So first year the change is 1, then it has increased by 2, it increased by 3, next it has increased by 2, again by 1. So you can see it can't be a linear equation. It will look like this, right? It won't be a linear equation. So there is a problem while you want to solve you want to solve it like a linear problem. If you want to solve it like a linear problem, there will be some discrepancies depending on the fact for which time duration you are calculating the slope for, because you can see it will be pretty close but not exactly same, because it's not a straight line. You can see it from the graph as well. Even you can eyeball it, as I said. So it's not a linear equation. So there will be differences depending on the D you are considering. So don't worry if you have different values, but it should be pretty close. It can't be like this, one for one duration you have 2.1, for one you have 0.5. It shouldn't be like this. Then you can't really use it. Okay. All right. So we have P naught, which is, I believe, 110. We have D, which is 2.17. Yeah. So clearly for P24, we have 24 times 2.17 plus 110. So in the year 2016, our assumption says it will be, let me use my calculator again, 24 times 2.17 plus 110, it will be 162.8. Let me see the value in the book as well. Yeah, you can see it's pretty close. They have 161.6. Again, as I said, it should be pretty close. Since it's not really linear, it looks like this. So you'll have different values. It could be different. Okay, so it depends on the model you predict. It depends on the model you pick. That means the D you pick and the P naught you pick. It definitely depends on that. If you start from a different P naught and if you consider a different time period for D, you'll have a different result. But once again, it will be pretty close. Okay, so no problems with that. Okay, and now we want to calculate when will it become 2000 or rather 200 billion gallons. Okay, now we actually have PN. Can you see that? Because in PN we have the final consumption, or whatever it is. For this problem, it's consumption of I guess it's oil, right? Or gasoline, yeah. So that's the consumption for the final year after a certain time. So this is actually given. The final consumption will be 200 billion of gallons. And from this, we want to calculate the time it will take. So that means we want to calculate what's our N. how many years after we'll have it. Okay, so what should we do? Once again, we know the formula, which is uh, d times n p naught, and what's dn here? So n is the value we're looking for. We definitely know p naught, which is 110, and for our problem, we have picked up d as 2.17 times n, it's 220. You just need to solve it to get your unknown value, which is n. And fortunately, we have seen problems like this in problem solving part. And if you remember, if you have one unknown variable, that means one unknown value which you are looking for, you can isolate that. So if I want to isolate this, I'll first isolate the entire part. So 2.17 of n will be 220 minus 110. I've just changed sides for this. Okay, so it has become minus 110. And since I'm going to isolate n, I can divide this by 2.17. I'm just dividing both sides. Okay, dividing both sides. Here I've subtracted 110 from both sides. And here I have divided both sides by 2.17. And if I do that, I'll have my result. Let's see. Excuse me. So 220 minus 100. Is it 220 or 200? Ah, gosh, it's 200. Someone should have reminded me. It's 200. Okay, so it will be 90 over 2.17. So this gives us 41.4, excuse me, 47. So that means approximately after 42 years, it will become 200 billion gallons. And we started from 1992. So after 42 years, I guess it would be 2034. Oh no, so it should be 41, my bad. It should be 41 years. Can anyone tell me why should we take 41 years, not 42? Anyone?
It's not above half a year, so you just
Exactly. Very good. Very good. So it's not 41 and more than 41 and a half. So if it's less than 41 and a half, that means if it's up to this, we'll take 41. And for more than that, we'll take 42. You know, that's a basic rounding procedure. So we'll take 41, so it will be 2023, 33. Let's see what they have. So they have, yeah, they have the same result, as you can see. Clearly, you can see, even though we had different D and P naught, we have the same conclusion because it's quite linear, but not exactly. So it should give you approximately the same result. So after, or rather in the year 2033, our gasoline consumption will be 200 billion gallons. That's our prediction. That may or may not be true. That's just a prediction, as we say. The model says that that it might be the year 2033, but definitely it can be earlier than that. It could be even later than that. It's just an assumption using this particular model. Okay, now take your time and see if you have any question. I'll post one homework today. It will be really smallish one. It will have only one question of 5 points. So once I post it, I'll definitely let you guys know via announcements. So look for that anytime after 4 p.m. today, because my class will end at 4. So I'll then set up the question and post the homework. And before we meet next time, I want you guys to go over example 4 and the definition exponential growth. Just a smallish pre-class assignment for you. And of course, try it now one. So look for example 3. Send me your work in my email or in Canvas for try it now one. And the definition of exponential growth. It's on page 180. You can see a box there. Okay. All right. Any question now?
Yeah, I have some questions.
Yeah.
Do you know when the My Open Math homework will be due?
Sorry?
Do you know when the My Open Math homework will be due?
Oh, I haven't really posted it. So once I post it, I'll definitely have it in the announcement. And once you log in, you will be able to see that as well.
Okay, and then you want the Try It Now 1 and all of that to you by Friday when we meet?
Yeah. So that's a pre-class assignment. So that's not really your homework, as we have been doing for the entire semester. So Try It Now 1 is our pre-class assignment. You can submit it via email or in Canvas before we meet, anytime before we meet on Friday. And I want you to go over this just to see if you can derive any question from this. I'll definitely show this once we meet on Friday, but that's just for your pre-class assignment. Yeah.